All right, guys. Hopefully y'all had a good Thanksgiving break. Enjoyed the rest for a little bit. But what we're coming back to is polynomial functions, chapter 4. So this is kind of extenuating from our chapter 3, our quadratics, because quadratics are a type of polynomial function, but we're going to be talking about more than those higher degree polynomial functions. So equations that have variables with exponents bigger than 2. So a polynomial function is a monomial, which is a number, variable, or product of numbers and variables. And a polynomial, poly meaning many, is a group of these here. Now this here is just the general way we can write any higher degree polynomial function. But here are some examples of a few that we have. So we have 5 that we're looking at with degree 0, 1, 2, 3, 4. If the degree is 0, the type of function that has a degree of 0 is a constant function. It just means we have a number. A sub 0 is just a number. So f of x equals negative 14 would be a constant function. If the degree is 1, it is linear. It's just equation of a line, 5x minus 7. Because the degree is the exponent, the biggest exponent connected to a variable that we have in the equation. And in this case, it is 1. 2 is a quadratic, which is what we covered in chapters 2 and 3. So the biggest exponent is 2, our x squared, making it a quadratic. Cubic and quartic. This is the first time we've kind of covered these this semester, this year. A cubic, x to the third, is our variable with the biggest exponent, which makes it a cubic. X to the fourth is our quartic, making it x to the fourth, being the biggest exponent. Questions on these here? All right. A few other things to go over before we start our first example problem. First one, standard form. A polynomial is written in standard form if it's written in order of decreasing power. So the variable with the biggest exponent goes first, and then decreasing from left to right. And the number without a variable normally goes last if we have it. Leading coefficient is the number in front of the variable with the biggest power. Leading coefficient. Because the numbers in front of the variables are coefficients, just the one in front of the variable with the biggest exponent is the leading coefficient. Now the other thing that we're going to have before we start our first example problem is defining what a polynomial is. And we could go through and describe all the characteristics or try to describe the characteristics of what a polynomial function is, but I think it's a little bit easier to describe kind of what it's not, what it should not have. And one thing a polynomial function will not have is a negative exponent. So the variable cannot have a negative exponent. Yep. So exponents aren't negative. So an example of this would be x to the negative 1. We cannot have a negative exponent attached to a variable. And the exponents attached to variables are not fractional. So we can't have, say, x to the 1/3 or x to the 7/9. It's all right if it's attached to a number, it just cannot be attached to a variable. Our next one. Any of the exponents cannot be variables. We can't have 2 to the x or y to the x, we cannot have a variable in an exponent. If we have it, it is not a polynomial function. Variables are not inside radicals. We can't have the square root of x, the cubed root of x. The variable cannot be inside of a radical. Variables are not multiplied together. And last but not least, variables cannot be in the bottom of a fraction. Specifically, the bottom of the fraction. We can have x over 2. We can have x in a fraction, but it has to be on top. It cannot be on bottom. So if we don't have any of these here showing up, so if there are no negative exponents, if the exponents aren't negative, exponents aren't fractional, exponents aren't variables, variables aren't inside a radical, variables are not multiplied together, and the variables aren't in the bottom of the fraction, then it is a polynomial function or expression. We ready for the first problem? So decide whether each function is a polynomial function. If so, write it in standard form. State the degree, type, and leading coefficient. So if we look at A, so to determine if it is a polynomial function, are any of the exponents negative? No. Are any of the exponents fractional? Or is there a variable in an exponent? Are there any variables inside radicals? Radical or variables in the bottom of a fraction? Variables multiplied together. Those, yes, it is a polynomial function. Now we do need to write it in standard form. So variable with the biggest exponent goes first. So that would be our negative 2x cubed, negative 2x to the third. Our next term that we would put would be the x squared. Is there one? No, so we don't have to list one. If it's not there, it's just not there. The term after that would be x to the first, or just x, plus 5x, and lastly our constant term plus a. So it was already written in standard form. We didn't have to do anything to it. Degree. Would be what? A little bit. So what would the degree be? Biggest exponent. Three, the type would be cubic. Because the degree is the variable with the biggest exponent. It states the degree, so the variable with the biggest exponent was our x cubed, so the degree is 3. Since the degree is 3, it is a cubic. So that's the type. And lastly, leading coefficient. Leading coefficient is the number in front of the variable with the biggest exponent. Negative 2. And that's it. Let's look at C first before we look at B. H of x equals negative x squared plus 7x to the negative 1 plus 4x. Is this a polynomial expression or polynomial function? No, why not? Negative 1. So this is not a polynomial function, or not a polynomial. Nope. Because of the x to the negative 1. And that's it. Because we only have to write it in standard form. state the degree, type, and leading coefficient if it is a polynomial function. This one is not, so we don't have to do any of that. How about B? Because?
Well, like you can't square root the x into 2. Or not square root.
So this piece right here, yes? Is the x to the fourth inside the radical? So the radical part doesn't matter because the square root's only affecting the 2, not the x to the fourth. So it is 1. Because the negative exponents, fractional exponents, have to be attached to variables. If they're attached to numbers and not the variable, that's fine. So this is, yes. So standard form?
Is it like the equation that they give us?
Kind of. So which variable has the biggest exponent? Square root of 2x to the fourth, yes? So it goes first. So square root of 2 x to the fourth. It goes first. Since it's positive, we don't have to write a sign in front of it. So, and then we decrease, well, what comes before 4? So is there x to a third? Yeah. So it would go next. So our minus 0.8 x to the third. Well, minus 12. Because if we did have an x squared term, it would go after the x cubed. If we had an x term, it would go after it. Biggest to smallest. So if there was an x squared term, we would write it after the x cubed. X would follow it, and then constant is last. The degree is 4. And this is a quartic. Because the type for this would be a quartic since it is a 4th degree polynomial function. Leading coefficient? Square root of 2. Because the leading coefficient is the number in front of the variable with the biggest exponent. And that's it. Questions on this here? We ready for letter D? Is this a polynomial function? Why not? Variable cannot be in an exponent, 3 to the x. Not a polynomial. Questions on these here? Do we need to see another example of one of these? Do you feel comfortable with these? Okay. Evaluate a polynomial function. So if we evaluate a polynomial function, so evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is equal to 3. So if we wrote it in function notation, we would say f of 3. But really, we're replacing every x in the function with 3. And at this point here, we can type the whole thing into the calculator. Well, we could type it into the calculator or do this by hand. Either one will work. 3 to the fourth is 81. 3 squared is 9. Now our 2 times 81 would be 162. 8 times 9 is 72. 15 minus 7 is 8. 162 minus 72 is 90. And 90 plus 8 is 98. So if we evaluate this function, when x is 3, we get 98. Because in the calculator, if we type this in, we can say 2 parentheses 3 to the 4th minus 8 3 squared plus 5 times 3 minus 7 is 98. Yeah, I don't know why it has that, because it's just mirroring what the TI-84 plus CE has, because if it has a lithium battery, it'll show the battery's charge up in the corner. So, as many math teachers have said, don't just use the variables in the calculator because they have to have a set value for them. Because if I just typed it in, 2x to the 4th minus 8x squared plus 5x minus 7, it tells me the value is 19,243. Well, that's a little off, yes? Now, there's a way that we can do this, because we said x was what? So we can type 3. Now, the button above on is store, S-T-O, store. And we want to store it as what? X. Because if I do 3 store x, what it's told the calculator is to make the value of x be. Now I'm going to select the equation again and hit enter. Now it tells us the value is. So that's why you need to be careful with using variables for this here, because we can set the value. Now, if the calculator is reset and a value has not been given to it, it automatically sets it to 0. Now this is somewhat helpful, especially if we're trying to find or evaluate multiple values for the same equation. Because if I wanted to say find the value or evaluate it for -3, we can say -3 store x, enter, come up, select this equation, hit enter. And for -3, its value is 68. Questions on this here? Questions on storing values, or well, evaluating values? We have one last thing. In behavior of polynomial functions. Now, when we talk about in behavior, what we're talking about is as the function increases to the left and to the right, the value of y, or what the value is going to equal, is going to do one of 4 things. Arrows. It's either going to go up or down. Now, out of all the different polynomial functions, there's only 4 ways that these functions will behave. And it's going to depend on the degree, because the degree is either going to be even or odd. Combined with the leading coefficient, because the leading coefficient is either going to be positive or negative. Positive. So if the degree is even degree polynomial functions will end up going in the same direction. They're either both going to go up or they're both going to go down. Now what happens in the middle, the reason that we have the dot, dot, dot is that there's many different things that can happen between the two ends, but eventually they'll both either go up or they're both going to go down. And if the degree is even, and the leading coefficient is positive, f of x is going to approach positive infinity as x approaches positive infinity. And f of x is going to approach a positive infinity as x approaches negative infinity. So x approaches positive infinity, negative infinity. As we plug in bigger values of x or smaller values of x, the y values will eventually go up. And if it's even and negative, f of x, the y values will approach negative infinity as the x values approach positive infinity. And f of x is going to approach negative infinity as x approaches negative infinity. Because what we're saying for even degree functions, they're eventually, the y values will eventually either both be going towards positive infinity or both go to negative infinity. It's going to make them both go up, or they're both going to go down. Odd degrees, they're going to go in opposite directions. One's going to be going up, the other is going down. So odd and positive is saying that f of x is going to approach positive infinity as x approaches positive infinity, and f of x approaches negative infinity as x approaches negative infinity. And degree is odd and the leading coefficient is negative. F of x approaches negative infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. And this is given to us in the chart in your note sheet, but I do also have it written on the board. And it does seem like a lot of information, but it's going to be a little bit easier once we see it in an example. So if we want to describe the end behavior of this graph here, negative 0.5x to the fourth plus 2.5x squared plus x minus 1. Well, what's the degree of this polynomial function? Well, the degree is so the degree is 4, which is even. Yeah, we don't need all the rest of it because since we're just talking about end behavior, it's going to be either even or odd with the degree. Since the degree is 4, it is considered even. The other piece we need is the leading coefficient. So the leading coefficient is negative 0.5, which is negative. Now at this point here, I would look back at the chart. So if it's odd or even and negative, it says that f of x approaches negative infinity as x approaches positive infinity. We also have that f of x approaches negative infinity as x approaches negative infinity. That's it. Because it says, all that's saying is as x, the values of x increase to the left and right, the y values are eventually going to go down. Negative 0.5x to the fourth. I think it was plus 2.5x squared plus x minus 1. Yep. So as we see here, as it increases left and right, the value values are going down. It does have a little bit of a ridge line in the center, up, down, up, but eventually goes down. But that's it. Questions on this here? Let's look at the next one. What is the degree for this function here? degree is, which would be odd. The leading coefficient is, which is negative. So if we look at this chart here, odd and negative tells us that f of x approaches negative infinity as x approaches positive infinity. And f of x approaches positive infinity as x approaches negative infinity. And that's it. Questions on this one here? Are you ready for the last one? Describe the end behavior of this polynomial function. The degree is 3, which is odd. Leading coefficient is 0.25, which is positive. If we look at our chart, it tells us that f of x approaches positive infinity as x approaches positive infinity. And f of x approaches negative infinity as x approaches negative infinity. So it's based off our table. Now the table is included in the note sheet. It's just not written the same way as I do have on the board because I don't have the chart included or the graphs. Also, it kind of has the evens on bottom, odds on top. Does that make sense? Because the one in your note sheet is kind of flipped sideways of what's on the board. Questions on this here?
Oh, okay.
Yeah.
I was so confused on how you read it.
Yeah, because this one here that I wrote on the board, it's just, instead of having odds, odd degree on top, even on bottom, it's just rotated.
So that one.
Either one works. They're the same thing, it's just they look a little different. But that's it.